In this video, we will look at the idea of half-life. Whenever we have exponential decay, or an exponential function with a growth factor less than 1, then the output of this function will cut in half over some interval of the input. As an example, suppose you consume 200 milligrams of caffeine, and then the amount of caffeine in your bloodstream changes by negative 18% per hour. Eventually, the amount of caffeine in your bloodstream will be half of the original 200 milligrams that you consumed. This idea is important, so we coined the term half-life to refer to how long it takes for the output of an exponential function to become half as large. Or more specifically, the change in input needed for the output of an exponential function to be 1/2 times as large. So, how do we actually determine the half-life of an exponential function? Right now, we don't have the tools to do this algebraically, but we can take a graphical approach to this. So let's look at this context we just talked about. So you consume 200 milligrams of caffeine, and the number of milligrams of caffeine in your bloodstream changes by negative 18% per hour. We want to know how long it takes for the amount of caffeine in your bloodstream to be half of what we originally consumed. So let's let t be a variable that represents the number of hours. So the number of hours since consuming the caffeine. Then we'll let c, which is a function of t, so c, which equals f of t, where f is this function that relates the number of hours to the amount of caffeine, we're going to let this represent the number of milligrams of caffeine in your system. So I'll just write number of milligrams of caffeine, but that's in your bloodstream. So we can actually write a function formula for f. So we could write f of t equals some expression using t. We know we start with an initial amount of 200 milligrams of caffeine, and this negative 18% per hour means that each hour that passes, we're only keeping 82% of the starting amount of caffeine, or the amount of caffeine at the beginning of that 1 hour interval. And so we have a 1 hour growth factor of 0.82. And therefore, our function formula is f of t equals 200 times 0.82 raised to a power of t. So if we want to know the value of t when we have half the amount of caffeine in our bloodstream, then we're looking for the value of t where f of t is equal to half of our original 200 milligrams. So f of t equals 200 divided by 2. And 200 divided by 2 is just equal to 100. So we're trying to solve this equation, f of t equals 100. And to solve that, we can just plot our function f as well as c equals 100 for this line right here. If we want to know when f of t equals 100, we could plot c equals 100 as well as our function here. So take a second to do that. Your plot should look something like this. We have our exponential function f, and then we have the line c equals 100 because we're looking for an output value of 100. And these two plots intersect at this point here, and this point has a value of a t-value of 3.49. So if we look down, we have a t-value of 3.49, which means that 3.49 hours after the caffeine was consumed, there's 100 milligrams of caffeine in the bloodstream. And so this 3.49 that we found down here is the solution to the equation that we were trying to solve, which tells us that 3.49 hours after consuming the caffeine will have half of the original amount of caffeine in our bloodstream, or we'll have only 100 milligrams of caffeine. And therefore, we call this 3.49 the half-life for the amount of caffeine in the bloodstream. This is how long it takes for the amount of caffeine to be cut in half. An interesting artifact of exponential growth is it doesn't matter how many original milligrams of caffeine we consume. We could have consumed 500 milligrams, or 600, or 8 milligrams. No matter how many milligrams of caffeine we consume, the half-life for the caffeine will always be 3.49. And so this half-life in this case was not dependent upon how many milligrams of caffeine we consume. It's dependent upon the percent change or the 1 hour growth factor?